Good evening to all. Today the topic is overhauling of MVSI. MVSI is an auxiliary motor used in conventional loco to cool the rectifier unit. So there is one blower motor provided for one rectifier block. So totally we have two MVSI, MVSI 1 and MVSI 2. MVSI 1 is in RSI block 1 and MVSI 2 is available in RSI 2. And as we all know that rectifier has some semiconductor devices which requires cooling. So for that purpose, we are using this blower. So it is a three-phase induction motor. And when the MVSI, that is the blower for a rectifier block, is working properly, that is in correct direction, the relay QVSI is picked and DJ will be closed condition. When it is not working, I mean, it is in the opposite direction, then QVSI relay will not be picked and DJ will be tripped immediately. So this HVSI switch is also used in the circuit to isolate the motor or the relay if any of the equipment is faulty. So this is the motor parameters. So it is we have two makes mainly in loco. That is Rengen and SHL. This is a Rengen motor nameplate details, and the same motor is used as MVSL also. So both the SL and SI are having same motor, same rating, same motor only. Only the hood, the outer portion is different. The enclosure is different, but the motor is same. So the motor parameters is like the RPM is 2880, and it is a 3 HP, that is 2.2 kilowatt motor. It runs in 415 volt and 4.6 ampere is the rated current. So the drive end and non-drive end. Drive end is the impeller side, and non-drive end is the side where no impeller is there. So drive end and non-drive end, we have 6306 C3 clearance bearing. So it is a type of bearing used in auxiliary motors, and the number is 6306. And we are using Servogem RR3 grease in that. Approximately 20 grams we are using to for each side, driven and non-driven side. The motor connections are 20K, 20M and 20N. That is both MVSI 1 and MVSI 2. Same cables are used. Sometimes 965, 66, 67 will be there. So this is the rated rating nameplate details of the motor. So overhauling procedure is mainly divided into 3 days actually. First day is dismantling, second day is overhauling, and third day is assembling. So first day what we are doing is that we have to check the motor condition before dismantling. We have to see if the motor is already earthed or it is having some issues. Sometimes the motor may be kept in the section due to some failure. So if we dismantle it and then if we are assembling it, the same failure will be there in the assembled motor also. So for that we have to check some activities. That is, we will have to measure the motor using a 1000 volt measure and continuity of winding, then resistance of the winding phase between the phases, inductance also we have to see, and the motor we have to run that motor and see whether there is any unusual sound or rubbing sound available before dismantling itself. That is the usual procedure. And then once we dismantle it, these are the main parts. Once we dismantle the motor, so this is the hood of the MVSI, and this is stator. When we remove that motor, we will get the rotor, and this is the end shield, this is the bearing, grease cup, and this is the stator, this is end shield, and this is the impeller of MVSI. So these are the main parts, and this is the grease pipe and grease nipple, where we have to apply grease during schedule. So these are the main parts when we dismantle the motor. So this overhauling procedure, we have to check the stator for this will have the winding. So we have to check the stator condition first day itself, and then rotor also. Some tests are there. So the main test in stator is the surge test. So once we dismantle it, we have to do the surge. That is surge pulse is applied in the stator winding, that is R between R and Y and Y and B and RY phases. So that pulse, that will be a high rise pulse. It will go once and it will be decayed. I mean, in the winding, it will be decayed, and it will be shown in the CRO. I mean that scope, oscilloscope. So that is displayed on the screen, and this is the standard waveform which we get in the surge machine. Around 3.5 to 5 kV we can apply. 3.5 kV usually we apply, and then this is the normal waveform. It will be like this between RY and YB, the RB phases. We have to check the surge, and this is the normal waveform. If there is any fault in the winding, that is any open circuit or earthed, then the waveform will be like this. So this is a surge example for face-to-face short, and this is a example for coil-to-coil short. Already these parameters are there in the SMI 149. So depending on this, we have to see the stator. And if it is failing in surge, if we don't get the standard waveform like this, we will have to reject that stator. So that stator will be rejected. So once stator surge test is conducted, we have to check the resistance, inductance, and measuring we have to do. Resistance between each phases, 10% we have to, we can allow. Like if it is more than, it is varying more than 10%, we have to say that it is abnormal. Resistance value or inductance value is abnormal. We are using a LCR meter to check the resistance and inductance. Then the first day we will divide it as stator cleaning. We have to do stator cleaning. Then after cleaning, we have to bake the stator using Dr. Beck varnish. So baking procedure is there in the SMI 200. So we are using Dr. Beck varnish, and we have to, after cleaning the stator with kerosene, we have to use the varnish, and after varnishing it, we have to put it in the oven for 120 degrees for 4 hours. So this is the stator baking procedure. And there is another procedure called as vacuum impregnation test that will be done during first overall of that particular motor. If it is a new motor, the first overall when we take it, we have to do vacuum impregnation. So that is another procedure. I will explain it. If it is not there, then we will do only stator baking. Then we terminal block, that cable lug, everything has to be checked as per the SMI 32. So this SMI 32 is for proceeding the procedure. It is a procedure for fixing the cable lug and cable condition. So it is basically we have to check the crimping of the cable. The motor phase cables, we have to check the crimping. So SMI 32 basically says that you have to pull the lug and see. Normally what we do in cable, same thing we have to do. If there is any problem, then we have to recrimp it. So that is SMI 32. Then second day, once, because we are putting it in the oven for 4 hours, so that first day will be completed. The second day for overhauling, we have to do this VPI, because if it is a SMI 86, if it is a new motor or during IOH locos, we have to do this vacuum impregnation. This is basically we are putting that stator in a vacuum chamber. That is there is a VPI plant in section. So we have to do this varnishing in under vacuum by creating vacuum, because that will ensure that all the varnish goes into the windings and all throughout the stator body. It will be spread uniformly. It will be covered, so that normal varnish we are doing using spray gun, so that will not be effective. This vacuum, since it is done under vacuum pressure, so it will be effective, more effective. So this is a one-time procedure in the whole motor service time. We are doing this only for one time, or if it is a new motor, first overall we are doing it. Right? Remaining all overall, we will do only normal varnishing only. So once we do this, it has to be the stator has to be dipped in the vacuum chamber. Then that resin, that is the varnish will be poured into the chamber, and vacuum will be created. That time for almost 1 hour, we can half an hour to 1 hour we can put in that chamber. Then after that we will take it out. In that time we have to check whether all the varnish is covered, the stator is covered fully in the varnish. And after that, taking it out, we have to again put in the oven for baking it. So second day that stator again it will be not available for overhauling. So if we are doing VPI, then the normal 3-day procedure will be exceeded by one more day. So that is only during IOH. So again we have to put that stator in the oven for around 6 hours. That is around 90 degrees. We have to bake it. So we are using Dr. Beck F40 varnish for VPI alone. Then the remaining part is the rotor condition we have to check. Rotor side we will have some dimensions and other aspects. The rotor also we have to check the rotor bar also we have to check continuity of the bar, that is growler test we have to do. And then bearing changing, that is one of the major overhauling procedure. In all auxiliary motors, every overhaul the must change item is bearing. So bearing, concern bearing we have to change. So that is explained in SMI 148. So SMI 148 basically it shows it tells us to use the correct bearing, which is new one, which is not reconditioned or not a fake. I mean, some rusted one or and all. So SMI 148 says that we have to use a genuine bearing for overhauling procedure. So some main point, some more points are there. Like we have to check how to check that bearing. We have to rotate and see whether any unusual sound is there in the bearing and all. So this SMI basically explains the same thing, that we have to use a genuine bearing. So genuine bearing of SKF or FAG we are using for overhauling. So that is a must change item. So we have to insert the bearing and in the rotor. So before that we have to check the dimensions of the rotor shaft area. So this SMI 16 says the friction limits on bearing of auxiliary motors. So this is mainly to check the bearing clearance. So bearing clearance, if you don't use the correct bearing, I mean, if you don't measure the correct, if you don't measure the rotor dia and bearing inner dia and all, there will be fitting issue. The bearing will rotate, or the bearing will be free to, and moreover the end shield also will be free, so it will be coming out. So mainly importance of bearing clearance is that to compensate for the temperature variation, because when the motor is running there will be a rise in temperature, so that time it will be expanding. So if there is no clearance, proper clearance, then bearing will be stuck, so it will create unnecessary unusual sound in motors. So any vibration, if it is there, that will be also dampened if you are doing the correct measurement. So we are using in MVSI 6306 bearing. So this last two digits into 5 multiplied by 5 gives the inner dia of the bearing. So based on the inner dia, we have a chart in the SMI, and that will give the inner dia. So the inner dia of the bearing will be 30 mm, because 63 not 6 into 5 30 mm. So 30 mm is the inner dia of the bearing. So shaft dia also, where the bearing is fitting, so that will be also 30 mm, but it will have some tolerance. So the shaft dia at bearing seat area. So this is the shaft dia, nominal shaft dia 18 to 30 mm. 18 to 30 mm, this is the tolerance, plus 2 to plus 11. So that much tolerance can be provided. Shaft in the shaft when we are inserting the bearing. And the same way, bearing radial clearance for 18 to 30. So 24 to 30, that is 13 to 28. That is the maximum clearance wherein that bearing can expand. So that is the radial clearance of the bearing. So this chart is common for all auxiliary motors. Depending on the dia, inner dia of the bearing, we have to find out the value. And another thing is that this is the outer riser and dia. We are using 18 to 30, 30 to 50. So this is the outer riser tolerance, 0 to minus 11. That is the tolerance. This is common to all motors. So depending on the bearing, we have to identify it. So once bearing is inserted, next thing is that we have to check the impeller DPT also. Impeller, every impeller we have to check DPT for any cracks, and after that we have to assemble it. So the third day it will be assembling. So as I told already, if there is a VPI done in that stator, then that VPI will be we have to clean it, because that will be covered. I mean, the whole stator will be covered. So we have to clean it. So that one day extra, the fourth day it will go to fourth day. If VPI is not done, then we can insert and the rotor. After inserting the bearing, we have to insert the rotor and we can do the run test in the third day. So sometimes when we are inserting a bearing also, there will be some free running, free rotation. Maybe that bearing may be not seating properly with the end shield. So that time we have to use Loctite. So this SMI 78 says that that outer razor, if that is rotating freely, so a thin layer of Loctite 609 should be applied in the end shield. And then we have to assemble that rotor, that bearing inside the end shield. So that will hold the bearing and the end shield properly, so that rotor end shield itself will not. I mean, the bearing will not be rotating freely. So after that, we have to assemble it. So assembling it, same opposite of what we done in the dismantling time. So this is how, as I told you, this is the bearing and this is the grease cup. So first we have to insert this grease cup, then bearing, then apply grease, then this is the end shield. End shield also, end shield will sit over the bearing outer. So after inserting it, it will be inserted in the stator. Then that grease cup will be provided here, and then finally impeller will be provided, and it will be assembled into the hood. So it is basically opposite of what we have dismantled. Then thing is that then this is the motor SPM test. Once the motor is assembled, we have to check for the vibration. So we are using a shock pulse meter. So shock pulse meter, we have to check, and we will get these two mainly these two parameters, that is A, B, C, D, and this green, yellow, and red. So if the bearing is in good condition, if it is a new bearing, it will be showing A. So it is a good condition bearing. If there is any improper lubrication, that is, if grease is not applied properly, then the shock pulse meter will show it as B or C. So that means there is some problem with the bearing lubrication. So grease is not applied fully. So again, we have to dismantle it. Again, we have to remove that grease and then reapply. Or else we can top up the grease and see using a grease gun. So C and D we will not accept. We will reject that motor. And this green, yellow, and red also, it will be displayed in the shock pulse meter. So this is basically for the lubrication, and this is for the overall condition of the bearing. So this is done during every overhaul of auxiliary motors. We are doing this in all auxiliary motors. And after assembling, we have to do the run test again. Since the motor is now assembled, we have to do the run test, that is voltage, current, and RPM we have to measure. And if it is a rewinding stator, then sometimes there will be problem with the winding layout. So the motor may run with a different speed. So since it is a MVSI, we require 2880 RPM. So if it is a rewound motor, then we are supposed to check the RPM. Otherwise, it will be more or less. So there was some cases wherein CPU was running with high RPM and all. So CPU requires less RPM, but CPU was running in more RPM. So that we have to check. So these are the tools we are using for measurement and all. So bore gauge, micrometer to check the shaft dia. So this is the bearing seat area. So we are checking the shaft dia using a micrometer, and bore gauge to check the end shield inner dia and all. And this is the shock pulse meter. So this is used to check the bearing vibration, bearing unusual sound or any vibration is there or not. So these are the general failures which we have encountered in MVSI. This is common to all axle motors. So either it will be bearing unusual sound or stator winding may be earthed or open, surge failed and abnormal inductance values. So abnormal inductance value we are checking in mainly for three-phase locos, we are checking in every IC schedule. And IR value we are checking for every IC in conventional locos. So inductance values we are checking during dismantling time, overhauling time only. Surge also we are checking during dismantling time only. These are only the common failures which we have encountered till now in MVSI. And rarely impeller breakage cases may there, but it is rare only. So these are the some of the failures which has happened. This bearing, this is called as the cage of bearing. So cage broken, and this is another motor, not MVSI, but same thing only will happen in MVSI also. So this cage is broken and bearing got jammed. This is another case of stator earthed. So this is black color. So some earth happened here. Stator is burnt, and this is bearing some unusual sound. So we have checked the bearing and some rust marks. So this is what I called, what I said in that SMI, that we have to check, use only genuine bearing with no rust and all. So this some pitting mark or some mark will be there, which will be creating some unusual sound while rotating. Some failures for the past years, that is from 2020 to 2025. So mainly, so these are the failures. So Ranjan and SHL make some for some 2020 we had a case of MVSI smoked. Smoked means it is basically earthed or coil burnt. And around 5 cases in 2021, 22. That is also unusual sound and burned cases only. 2022, 2023, around 6 cases. Unusual sound and MVSI earthed. 23, 24 also MVSI 2 unusual sound and some smoked cases. This one was a line failure, 28647, and 24, 25 a cage broken. So this what the cage broken I have shown that in the bearing image. So that one case in 24, 25, in 25, 26 now up to now no failures. So these are the overall procedure. Further class will be taken by Dinesh during his topic. So he'll go deep in testing and all in motors. So this is the overview. This is the same for all motors, same for all accelerator motors.